Now, today I will discuss DPP3 application of special integral formula. Okay, for IIT-JEE foundation batch. I have already discussed DPP1 and 2 for application of special integral formula. I have already discussed in previous session. Okay, so today we will discuss three questions 1, 2, and 3 one by one. Okay, see very carefully. Now, question number 1, integration of cos x upon under root sine square x minus 2 sin x minus 3 dx. So here let if sin x this be equal to t, then cos x into dx is equal to dt. So cos x dx is replaced to dt, and that value, that is t square minus 2t minus 3. After that, dt divided by under root of that one, t square minus 2t plus 1, adding, then we got minus 4. After that, dt divided by under root, here t minus 1 to the whole square minus 2 square. Clear or not? Okay, I know that I have already discussed dx divided by under root x square minus a square, that is log of x plus under root plus c. Okay, this is the formula. So apply, x is replaced to t minus 1, so log of t minus 1 plus under root t minus 1 to the whole square minus 2 square plus c. Here t is sin x, so log of that one is written log of x sin x minus 1 plus sin square x minus 2 sin x minus 3, and plus c is the right answer. Okay, that is question number 1. See very carefully. Simply sin x is tan t, then cos x dx dt, then after that solve and find the answer. Okay, now question number 2. Now question number 2, if you see very carefully, under root, that one basically written as divided by, okay, now multiply and divide into dx. After that, and in denominator, that is sine here into dx. Okay, in sine x minus alpha into sine x plus alpha into sine x minus alpha, that value is sine square x minus sine square alpha. Okay, if any doubt why that value is written, so simply you know that cos a plus b, that is a minus b minus cos a plus b is written as 2 sin a into sin b. Okay, simply here a is and b is x minus alpha. So 2 sin x plus alpha into sin x minus alpha is written as cos of x plus alpha. Okay, and minus cos of x plus alpha x minus alpha, and that value is written as cos 2 alpha minus cos 2x. Okay, and that value is written as simply 2 sin square alpha, here 1 plus 2 sin square x, 2 is common, that value clear. So after x 2 simply clear or not, how can prove clear. So simply sin x cos alpha minus cos x sin alpha whole divided by under root of into dx. Clear. Now sin x clear, and here sin alpha is common, then we got cos x whole divided by okay. Now after that, if you see very carefully, that value is I1 I2, that is equation number 1. Okay, now so first of all solve I1. Here sin x dx divide by in denominator, that value is written as 2 1 minus clear. Now that value is written as sin x dx whole divided by under root, that one is written cos square alpha minus okay, let okay, now put here Okay, that is sin inverse t upon cos alpha plus c1. T is basically cos x. Clear or not? Okay, that is I1. Now we have focus on I2. I2 basically cos integration of under root of sin square x minus cos square. Okay, now how can do it? If let sin x this be equal to t, then cos x dx this be equal to dt. So dt divided by t square minus, okay. So simply here that one is written as log of t plus under root plus c2. So log of t is basically how much? Sin x, and that one is that is I2. Now put this value. So I this equal to, and this is I, cos alpha minus sin alpha into I2 cos alpha I1. I1 is minus sign, so here minus sin inverse cos x upon cos alpha. Okay, minus sin alpha, and what about I2? I2 is basically log of into log of sin x plus under root of okay c1 plus c2, that is c. After that adding constant. So final answer is I this equal to cos alpha into sin inverse cos x upon cos alpha minus sin alpha log of plus under root plus a new constant c. Okay, clear or not? See very carefully one by one. Okay, if any doubt then comment it. That is question number 2. Now next one I have discussed question number 3. Now question number 3, if you see very carefully, that one is written 2 into 2 sin x cos x minus cos x and that one is written, and that one clear, that is 4 into cos x dx, and denominator, and that is plus 5. Okay, after that let here then cos x dx, this be equal to dt. After that that is 4t minus 1 into dt whole divided by, okay. Now how can resolve this type of problem? First of all, if you see very carefully, 4t minus 1 this is equal to a into differentiation of t square minus 4t plus 5 divided by dt plus new constant b. So 4t minus 1 this is equal to 2t minus 4 into a plus b. Okay, now 4t minus 1 this is equal to 2a into t. If you compare 2a this is equal to 4, so what about a, that is 2 minus 4a plus b this is equal to minus 1, 4a minus b this is equal to 1. Okay, so what about b? B this is equal to 7. Clear? Now this value put, then we got 4t minus 1 is replaced to a means how much, 2, 2t minus 4 plus b is 7 whole divided by t square minus 4t into dt. Okay, how can do it? First of all, if you see very carefully, that is 2t minus 4 and denominator 4 dt, and that one is written 7 dt divided by, that one is written as 4t. If 4 is adding, then and then 4 is subtracting. Okay, if you see very carefully, that is log of t square minus 4t plus 5. That one is basically integration of dt upon t minus 2 to the whole square plus 1, a new constant c1. After that 2t log that one is 7 tan inverse t minus 2 plus final, a new constant c. Okay, now what about t? T basically sin x. Okay, t basically sin x. So 2 7 tan inverse sin x minus 2 plus c. Okay, this is the final answer. That is part question number 3. Okay, so question number 3 completed. Question number 2. Okay, and that is question number 1, and this is DPP3. Okay, make it.